Okay, well, we're going to move back to Ben now, who's going to show some early results of a project that's quite a local scale one, a ward level project that's modelling time use.
I'm going to show you some maps.
Excellent.
Finish the day off. And actually, we have plans to track people, I'm pleased to know. I wanted to shift the emphasis a little bit away from thinking about maybe whole countries or whole populations or whole groups within sort of populations. Think about space and what's happening in space, in particular what's happening in respect to how people use time in space. And the reason I want to do this is to answer some of these questions. And I'll take you, this is essentially the menu, I want to take you through some of these things. I want to explain why we think that spatial patterns matter, probably even more than some of the other kinds of patterns that we've been talking about. The problem with the census is it doesn't give us a lot of the patterns we're interested in, and I'll explain some of that. So we've got some methods for estimating spatial distributions. I'll give you some examples, and I won't go too much into the method detail unless you really want to. It's getting a little bit late in the day for that. And then I'm going to give you some examples about modelling change, which in a way ask you to forget that I showed you those complicated modelling slides earlier on, because this is almost the snooker ball approach. Okay? And I'll explain why I'm having to do that first, essentially because it's easy. Now, we may be interested in regional differences. Political debate is often couched in terms of regional differences. And so the regions that we tend to use for analysis are these, which are the government office regions, so they correspond to the development agencies. So ours in the eastern region, for example, is EDA. And I'm going to show you mostly maps of the eastern region, so hopefully you'll be at least more or less familiar with some of the geography of that. You can do this with just about any of the large government surveys and nearly all market research surveys. They will have some sort of regional variable in there. So you can look at the disparities in internet time, this is a main activity, across the different regions. You've got elephants living
yes.
And then if you look at the households who have internet, so obviously they're going to be spending more on it than the average population, you can see how some of those regional disparities actually disappear. So the Welsh catch up with London as do with those in Northern Ireland. So the trouble with this, of course, is that, well, a region is a very large place, actually. There's an awful lot of diversity within that region. We could assume that there wasn't. So if geography didn't really matter very much, then we would have a map that looked a bit like that. So there would be different mean values for each of those areas. Now, the problem is that it looks rather more like that. Geography matters an awful lot. This is what's called the Townsend Index, which is an index of deprivation, multiple deprivation, based on the last census. This is East Anglia, and you can see those areas which have multiple deprivation according to this index, up towards North Norfolk, some areas around the south coast here, and Great Yarmouth, where the fishing industry took a dive in the late 80s, early 90s. So you can see that there's a huge amount of variation within regions themselves. It's no good thinking about things at the regional level, because we're interested in, I think, what turn out to be actually local problems. We're interested in local action, but most important, the localisation of policy. And what I mean by that is that there are national level policies can have very different local specific effects. And in order to do any kind of analysis of policy implications and policy impacts, we've got to have some way of translating our national level stuff into something like that. Where's it going to make a difference? For whom? Why? What's it going to cost? What's the benefit? And I'm going to give you some examples of how we can do this with data that's actually, in a sense, impossible to collect. And geography matters to a very wide range of actors. That's the whole point of the reason for the census, of course. It matters to infrastructure companies who are putting stuff in the ground, telcos and other utilities. Perhaps telcos don't like to see themselves as utilities anymore, but anyway. It matters to distribution companies, the post office, the Daily Mail, Royal Mail, all the rest of it. It doesn't matter that there's an awful lot of virtualisation, or whatever you want to call it, dematerialisation of goods and stuff in this new society. They're still going to get shifted around. You might be buying them online, but they've still got to get to you. So there isn't that much dematerialisation of the distribution of stuff. In fact, there's probably even more distribution of stuff than there was before. So understanding where those people are who might be calling on those services and infrastructure is very important. It matters to policymakers because decisions are taken at the local, unitary or the borough level. It matters to MPs. They get elected spatially, actually. From their point of view, it's rather unfortunate. They don't have a sphere of action at the constituency level. It can only work through the local authorities. So things need to be understood at different spatial levels. And of course it also matters to people, because we live in areas, we live in neighbourhoods where we're interested in access to amenities, services And all of that ties up with this notion of neighbourhood cohesion. So space matters, okay? Geography matters, and the thing about geography is everything is linked to everything else. But the close linkages turn out to be more important. Okay? And that's still the case now. So we could just rely on the census to talk about spatial stuff, and it does all of these things, and it does them extremely well. And we can extract that data now down to what's called output area levels, which is about 120 households. They fiddle with the data so that they don't release a count of one, which you can say, oh, that's me. Okay, so they've merged some areas so that won't happen. But basically, you can get some very good small area data on these sorts of variables. So here's an example for the eastern region again. This is the proportion of all males in employment. And what you're seeing, I picked out there, is actually American Air Force bases. So in other words, in those particular locales, the proportion of males is virtually all in employment. But this is not the case in other areas. Great Yarmouth up there, Norfolk coast. Anybody heard of Frinton? They used to say Harwich for the continent, Frinton for the inn. It's a retirement. So essentially what you can see is that the distributions are highly varied and very focused and specific. You may not know this, but you can't actually get income out of the census. Do you remember filling in an income? No, you didn't. It has not ever been asked in the UK census. It probably will never be asked in the UK census because they're absolutely petrified of non-response, refusal, harming the one number, the idea that we can capture everybody. It's common practice in Australia, Sweden, Finland. They don't worry about it there. States as well. But it will never happen here. Well, it's unlikely to. They'll probably publish next week. They're going to ask you in 2011. But what you're looking at here is the average household income that we've estimated using a method devised by Dimitri Bars and Graham Clark at Leeds over the last 4 or 5 years, which we've taken and amended and I think improved. We still work with Dimitri quite a lot on this. So London's down here, you see the whole of East Anglia up here. What you can see straight off is what you would imagine to be a core periphery. So here's London influencing most of the south-west of the eastern region. Then we have this sort of anomaly, and up here it looks quite peripheral. But you've got this channel of wealth going up here, which turns out to be the high areas of Suffolk. Well, they knew about global warming, right? So the sea levels coming up. But of course, you've got Norwich, so that pulls stuff up in that direction. You've got very interesting agglomerations of industry and also higher education in Suffolk. And you've also got a railway line. What you're looking at here is actually the distribution of commuters and the wealth that generates into the local area. Because people now will commute from Norwich. I live about here, it's about an hour and 40 minutes down to Liverpool Street. So what you're seeing through our estimations, remember this is not real data, this is synthetic, we've estimated it. We've done it by combining the expenditure and food survey, which is a public data set, and the census, to produce an estimate that actually turns out to make some sense. Which from my point of view is fantastic, because it makes some kind of sense for income, maybe it'll make some kind of sense for other sorts of variables as well. So I'm going to show you one or two others. For example, we've done an estimate of the distribution of mobile phones. This of course is 2001. Okay, so there was some heterogeneity. You did that now, it would all be brown, probably, except for some few specific areas that match onto those multiply deprived areas from earlier. At this point in time, if you got up to someone in the street and said, have you got a mobile phone, it wouldn't have told you a great deal about them. If you did it now, it is a key indicator of multiple deprivation. In fact, it's one of the best. So you can save all that time doing the indices, you just walk up and ask people about mobile phones. You get, or had at that point, some sort of core and periphery there, but it's not particularly marked. If you look instead at an estimate in 2001 of the distribution of internet access, you see a reflection to a greater extent of that wealth distribution I showed you just now, the income distribution. So you've got this London effect, then you've got this periphery effect with the isolated area of Norwich stuck out on its own in the North Norfolk. This, of course, will also have changed. Now, what I'm showing you here is in some senses a validation. The red is what we estimate for each of the government office regions, and the blue is the original survey data. So different levels of analysis, but they're aggregated to the same number, if you like, for each region. And You can't see the detail, of course, but what you can see is that there are no big holes. So again, we have some confidence that what we're doing here in terms of estimation is producing results that are more or less reliable in some sense. Yeah, I don't want to go into the detail of how we can do that. But, we're switching now to time, and this is where we start to bring in some of the time use surveys. So this one is using the ONS's 2000 time use survey data set. So again, this is history. There is now one from 2005, which I know Kimberly's worked on, which hopefully will be out and available for analysis fairly soon. And you can see, again, the distribution of working time. So this is the amount of time. It's actually an average across everybody in a household. So it's, if you like, the entire average household working time. Okay. So again, you can see where those work less people are distributed, or where our estimates of their distribution are. Switch to social time. This was defined as social life and entertainment. These are quite coarse level categories, built up from a lot of very fine grained categories, and of course we could argue till the cows come home about what should be in there. But just as indicators, you can see this as a very much flip of the work. So if you're not working, you're having fun. Where do you live to have fun? Well, you live in retirement communities, and you live in the tourist belt of North Norfolk, there on the beach. Again, certain things seem to produce some sort of sense to us. And just for Paul's sake, I threw in this one, which is volunteer works and meetings. Now, this is where we start to run into some smaller difficulties with this method. You probably can't see it, but there's now starting to be bigger differences between the original data and our estimates, because so few people do this. So in other words, where you're trying to estimate their distributions across small areas, which is what we're doing here, you're running into a problem, which is in expenditure surveys, it's called the zero reported spend. Did they not report it because they don't do it, or did they not report it because they didn't do it that week? You don't know, because it's a very rare thing. Okay? So these sorts of things are starting to be much less reliable, but on the other hand, they do follow some of the patterns that we know from analysis of the survey data. This sort of stuff depends on certain kinds of social demographics, and the guts of what we're doing here is taking variables from one survey that match variables in the census, and we're essentially merging them together on the basis of those variables. It's a bit more complicated than that, but that's kind of the idea. This one perhaps is now starting to get a bit more interesting. This is media time, so it includes TV, video, radio, and so on. We could break it down into those subcategories if we wanted to. What you can take away from this one is that, let's imagine you're an infrastructure company or a service provider, and you're interested in taking a portion of media time, because maybe you're interested in advertising revenue, maybe you're interested in subscription services, something like that. What this is telling you is that your return is going to be highest, potentially for groups you haven't actually considered, perhaps, as your first point of call. Because remember, these were largely the leisure retired groups here. But it leads you to a second problem. They're not in the core urban areas where you can easily get your stuff to. So suddenly you've got a way of thinking about where your potential revenue might come from, if it's usage that's going to generate your revenue. But at the same time, you've got a way of thinking about the costs. What's it going to cost to get fibre to the North Norfolk coast? Oh, but let's not do that. Let's do it somewhere else. Now we can start to make use of a bit more fine-grained data from the ONS type of survey, because one of the things that it asked about, as we've been alluding to before, was not just what you were doing, but how you were doing it. So in other words, this is a category which is about information searching online. So I was looking for information, it wasn't in the library, I was doing it using Google or what have you. Okay? So we're giving a bit more detail to internet usage. What are you actually doing? And if you do this kind of estimation, you can see it sort of reverts back to that work, income distribution. So you have another core periphery with this train line effect. Here again, we've started to see some differences in estimations, because we're dealing with something that's very rare. It was certainly very rare in 2001. If we did it again, I think it would work an awful lot better if we had data from now. Of course, we don't have a census from now, but I'll come back to that in a minute. So compare that one, right? Actually, before we do that, let me remark, before somebody picks you up on this, remember the internet access distribution looked a bit like that. So you're going to say, well, that's just because those people have got the internet. No. what we've done here is actually to control for that by dividing by the proportion of households in each area that have got the internet. So in other words, what you're seeing is that the red ones are those who are doing it much more than you'd expect, even for the distribution of internet access. Okay. Look at this one. Complete reversal. This was a time-use activity, which is communications. So it's any kind of email, instant messenger, Usenet, news, all of those sorts of things. If you get into the survey data, it is distinctly different. The kinds of people who are doing this are distinctly different. And therefore, when you produce distributions like that, it is also distinctly different. So in other words, the people who live here are the kinds of people who do this much more than you would expect on average. And people in the dark blue are those who do it actually rather less than average, the white being those who do it average amount. Okay, so again, you're getting spatial distributions which match onto certain kinds of social demographics. So, okay, pretty pictures, interesting patterns, they might guide you, let you do some interesting guidance, investments or whatever. What we really want to do is model change. Now, I mentioned before, in a way, there's two kinds of things that you can do here. You can think about instant change. So if we woke up tomorrow, somebody had changed the tax system, how would the money flow look? Nothing else has been done. It's then going to take time to fiddle out and work out and co-adapt and all that complex, messy stuff I talked about. But just that's an instant change. Now we can do that kind of modelling. It's called static microsimulation. It's actually quite easy because there's no time-based dynamic. I haven't got to say that's changing. I've got to feed that back into the model. A much better way of doing it is this, which is where you take account of processes of change. So you have dynamic feedback. So this changes, so that changes, so how does that feed back into our model? I'm not going to show you examples of that because it's not very easy to do. I haven't done it yet. Because it requires this, which is a dynamic, and in this case, spatially dynamic model. No one has got that working yet, not even the government's tax system. If you look at the pension models, they're in fact doing that totally, well, they're doing it dynamically, but they're not doing it in space, which is a bit weird when you consider that the distribution of pensions has a huge effect on local authority resource budgets. So what we're going to do is we're going to play a snooker ball model. It's going to be static, so it's an overnight change. And we're going to see what happens if we have universal access in the home to internet. And the way we do this is we simply have it's a regression model, but you could imagine we're trying to predict this based on whether they've got household internet access and some other stuff. Similarly with online communications. And the other stuff are the things that might make a difference to the way that happens. So we're going to take account of things like wealth, education, and all the fairly standard social structural variables.
So you mean adoption rather than access?
What?
99.6% of the population do have access.
Sorry, as in have it in the home, and yes, yeah, so adoption is. So then what we do is we calculate effectively what the coefficients that sit into this equation are now. Okay? And then we hold on to them. And then what we're going to do is we're going to give everybody internet access. Uptake. So everywhere that there was a no then, we're going to turn it into a yes. So everybody's yes. And then we recalculate these two variables here. That's a static microsimulation. Okay? Standard practice in economics, actually. And this is what happens if you then look at the new distributions of the time spent with online information seeking. Okay, so over here, the blue was how it used to be, and the yellow is how it was changed, what it's become. So in most cases, you've added about a third, perhaps a bit less, to the regional average amount of time spent doing this. In some particular areas, you've got some very significant, very concentrated change. 600, 700, 800, 900% increase in the average time spent doing this. In others, like white, blue, some of the darker blue, it was negative. Well, how can it be negative? It's negative because in those areas, what's happening is that you are getting people that you've got online who actually do it rather less than the old lot. So they drag down the average for that area. Okay? So you're still seeing heterogeneity, social heterogeneity, even though you've given everybody internet access, this universal access. Okay? But you look at what's happened then with this variable, and there's an indicator here, which is the proportion of people who've got no qualifications. That's one part of these multiple deprivation indices. So in other words, what you're looking at is, it's made a huge difference in those areas where there were lots of people who had no qualifications. Okay. Well, you'd expect that because it's also those areas which probably didn't have internet access, which is one part of it, but that is only one part of what's changing. Now you can compare that with what happens for communication, and it's much more diffuse. You don't see the same kind of huge significant changes, partly because this behaviour was actually much more diffuse anyway. It didn't have quite such a strong spatial and social distribution. But also, overall, the increases are much higher. So in fact, by giving everybody a universal service, you're increasing the communication activities they do much more than you're increasing the information seeking activities, which gives you an indicator of what we know from other work. What's important about internet access is actually access to people, not information. Okay. And this is borne out when you use that same indicator. You basically have no relationship at all between this deprivation indicator and what's changed. It's a mess. It's a model that's random. Okay. It may be that other indicators would work. We haven't exhaustively tested them, but you can see the point. So, what can we take away from this? Well, firstly, if we had universal access in this sense, you're still going to have social structures, social divides, digital usage divides. The information seeking seems to get changed. Remember, this is a very, very simple model. Seems to get changed at the geographical and the social margins. Can only be a good thing, presumably. But on the other hand, the change in communication activities, communication behaviour is much larger and also much more diffuse and widespread. So, we're still going to have usage divides, whatever we do. I showed you the pictures of the, not the change pictures, which is what I showed you, but the maps of actual levels, and you still get social structure, social divisions. It's not going to go away. You're not going to change that by giving people internet access. But what we can do is these three things here, which I think are vitally important to any kind of investment, whether you're in industry or public sector or whatever. Because you can start to assess the kinds of benefits you're going to get at the localised level doing this. Now, if we had some sort of model that said, if we do more sort of certain kinds of activities, there will be certain social benefits, and we can model that through social capital, for example. We know how to do that. Then you can look at the social benefits, the local social benefits, and set them against the local social costs, the local infrastructure costs, or whatever it is. So you can start to do some very informed, localised cost-benefit analysis, which in a way is kind of a long-winded response to Keith's question about how to do our business cases better. One way to do it is this. Or this is part of one way of doing it, isn't it? So that's all very well. We want to estimate these distributions so we can do a bit of modelling on it. Fine, I'm just showing you some examples. What we'd really like to be able to do is to go forwards in time. If we can project some of this forward, we need to do two kinds of things. We need to project technology uptake. Well, there's fairly standard ways of doing that, forecasting. But the more difficult thing we need to do is to create ourselves a synthetic census. Because there isn't one for 2011 yet. There won't be one in 2016. There might be one in 2021. So we need some way of projecting the census forward. Now you might think, oh, that's easy. Unfortunately, about 60% of the boundaries changed between 81 and 91. About 45% of them changed between 91 and 2001. Nothing stands still. It is much more complex than just taking a unit area and tracing it over time. There's ways of doing it which we can work with. And once we've done that, we want to be able to analyse some of these scenarios to see what the relative costs and benefits are. So, where we've got to, I've shown you some examples of that. We have actually managed to get some of that working, and the rest of it is the ongoing work of the project, along with some of the other things that Paul and Caroline are talking about.
Okay, thank you very much, Ben. As a geographer, I find that absolutely fascinating, bringing it back to geography. Do we have any questions, or I suppose just to, as we are coming to the end of our time, other questions to other panellists as well? So we'll start here.
I thought it was like you were a magician about to, but we were sort of waiting with bated breath as to what was going to happen. But the problem I have is, what if your assumptions are wrong? For example, what you said about mobile phone use, I actually found the reverse was true. You suggested that people in deprived areas don't have access to mobile phones, but in 2001 I was doing research in deprived communities, and we found that there was much, much higher usage of mobile phones than there was in other areas in the city, because people in the more deprived areas weren't able to get landline phone accounts because they don't have a bank account, and they didn't want one because they couldn't predict what was going to be spending, or what they were going to be spending. So they had the mobile phone because it was prepaid. They knew they could spend £10 a month or whatever, and it was cheap and it was accessible. Yeah,
I would absolutely agree at that point in time, and I think the data sets here actually probably predated prepay explosion by about 6 months. So, which is why I said if you'd done it then and asked people, but now it doesn't work the same way. I absolutely agree that things like prepay change the shape of the uptake of mobiles, and in fact they are changing the shape of the uptake of internet access too, because it's now becoming a controlled fixed cost. It's not a multiplier of your time online anymore.
I mean, this is the problem. I mean, it's all interesting stuff, but the entire basis for the technology that you're based on has completely changed in the 5 or 6 years since you got that data set. I mean, we've already touched on mobile, broadband access. I mean, the cost of broadband, actually connectivity has dropped. I mean, there's so many things that have changed in that period. How valid will any conclusion that you come to as a result of this be? In terms of planning policy?
I think when you're looking at social activities and social processes sort of further up the chain from the infrastructure, I think it becomes much more valid, because they're the kinds of things that are going to go on no matter how you deliver the activity or the service or whatever it is. But I think what we were modelling was exactly the uptake of internet as we understood it at that point in time. Now, it is actually quite easy to use the same methods to do modelling of something which is different, as long as you have some assumptions of how it relates. So, for example, if it was the case the kind of internet we were talking about was very sensitive to income, the uptake of it was very sensitive to income, then you can model it like that. But if you're coming on and saying, look, I've got this technology which is going to be insensitive to income, and it's going to be like this and like that, you can build that model into it in the same way. So in other words, what I'm saying is if you have the right data sets, it would actually be relatively straightforward to do the estimations in exactly the same way. The critical thing is having those data sets. What you're asking about is to be able to do essentially scenario analysis, where instead of the relationships being as they are in the data, it's a new set of relationships which you're modelling, which is a scenario, and that's exactly what this is designed to do. And some of the work that we've been doing, for example, a separate piece of work which is using the same methodology for BT, and some of the work that we're doing there is looking at can we model the background of broadband uptake through their knowledge of where the network is, and normalising some of these results on the basis of that. That's one way of doing it.
So, for example, when in a couple of years' time everyone has a mobile phone which has wireless internet access, you're saying that the existing models you have
what that means is what I called internet access there is not now what internet access is known to be.
Right.
So those things change. But if you were to say that the kinds of people who are going to get that are like this and like this and like this and like this, I can still show you that. That's easy. Yeah. Because what you're coming to me with is a knowledge of how that new device plays into the social characteristics of some people. And it's the social characteristics of the people I'm mapping, basically. And if we have a model that links that to some kind of service or technology, then it just comes with it. You see what I mean? Yeah. Otherwise, it's a real problem.
I think the problem with forecasting is that we don't know what the technology is going to be or how it's going to be used. So the technology side of it's very important, but also we don't know what people's attitudes are going to be, attitudes towards the technology. So we're assuming increased take-up, and people in 10 years' time will still want a mobile phone, or they'll still want the internet or whatever. But for all we know, attitudes could flip reverse or whatever.
If we go back to here, and what you're talking about is actually this level of modelling, which is something that we started to do in some different work, where you're saying, okay, 60% of the population are like this, therefore they're never going to get it. We've got to fill up the 40% and then wonder how are that 60% going to change in some modelled way, which could involve a change in the kind of device. It could involve television, PCs looking like televisions or something, okay, which is then how you start to do the dynamic modelling. So you're allowing your population to change its nature over time. But you can only do that with some sets of assumptions and models. Otherwise, it just flows away with you.
I can see why you haven't done it yet. Good luck.
That's why, that's in a sense, what we're trying to do is take some methods from economics and apply them to something which is inherently more fuzzy.
Mm.
Any other questions or comments? Okay.